Hello, welcome back to Math 7 with Mr. Passon. Today we're talking about percent error. So let's go ahead and make a copy of the slides. Alright, so again, today we're talking about percent error, and first thing we need to talk about is absolute error. Absolute error measures the difference between the approximate value and the actual value. So for example, I have a meter stick. I'm assuming that it's a meter. It's probably a tiny little bit different because it's made out of wood, and wood expands and contracts and it dries out and changes shape slightly. So my meter stick isn't exactly a meter. It can be solved by finding the absolute value of the difference between the approximate value and the exact value. So let's go ahead and put an absolute value symbol in there. A minus V, absolute value. That vertical line is above the enter key normally. Alright, use your understanding of absolute error to answer the questions below. So a science experiment calls for 150 milliliters of water, but Simon measures out 147. What's the absolute error? So we take the absolute value of our actual 147 minus the expected 150, and that equals the absolute value of negative 3, which equals 3. Okay, let's look at example 2. A student measures the mass of an object to be 56 kilograms, but the actual mass was 53 kilograms. What is the absolute error? It's the absolute value of 53 minus 56. That again is the absolute value of negative 3, which equals 3. Percent error compares the absolute error to the actual value. Make that a bit smaller. It's in the line. Alright, so when calculating the mass of an object in science, we're often going to be interested in the relative error. So we're going to take the percent error equals the approximate minus the exact divided by the exact. Alright, and again, we're thinking of percent as out of 100, so we're often going to be converting from the decimal version to the percent version. Let's take a look. During a school assembly, Miss Quinn takes attendance and counts 356 students, when in actuality there are there were 376 students. So again, let's remind ourselves of the formula: absolute value, actual minus measured divided by actual. So that's going to equal 356. Oh, let me get the calculator, type it in right. 356 minus 376. And I'm going to put parentheses all around that to remind myself to divide by 376. Alright. And in fact, even better than parentheses would actually be my absolute values, which I'm supposed to have. So let me change that, and let me put it in here. So I've got the absolute value of 356 minus, was it 3, and then 376 divided by 376, the actual. And we get 0.053, so that is approximately 0.053, we'll just keep going, 19. Put a little dot at the end. And in our case then, that is 5.3% about. Alright, let's go ahead and take a look at slide 4. In a crowded arena, the 250 seats are counted. If there was 20% error at the count, what is the range of acceptable seat numbers? So, let's figure out what 20% of 250 is. So we expect there's somewhere between 200 and 300 seats. And we got that because we did 250 minus 50 for the lower bound, and then 250 plus 50 for our upper bound. So 250 was our estimate, and then we know we could be off, but we could be over or we could be under. So if we have over, we're going to say, oh, well, we think we have up to 20% error, so we're going to add 20%. If we have up to 20% error in the other direction, we're going to have subtracting our 20% off. Alright, so let's go ahead and look at page 2. Read each of the situations below and answer the questions using your understanding about absolute and percent error. Several students are competing in a science club competition to build a car that will travel exactly 10 meters. The distance that each student's car travels is shown below. What is the absolute error of each one? So Emily's 10 minus 9.2 is 0.8 meters. Jerome's is 0.6. And Marcella's is 0.2. What is the percent? So, to calculate the percent error, we take the absolute error, divide by our amount. So we've got 0.8 divided by 10, and that equals 0.08, which equals 8%. Let me make that just a little bigger so everything fits. Put that on a new line. This one is 0.6 divided by 10, which is 0.06, which is 6%. This one is 0.2 divided by 10, which is 0.02, which is 2%. Based on the information, what does the smallest percent error indicate? That's a good question. What do you think? Go ahead and fill that out. Okay, in my mind, the smallest percent error means that it was the closest to 10. So we could say that because the objective was to get close to 10, the small percent error a small percent error. Percent means the car is very close to the objective. Alright, let's see, did Jerome have the smallest percent error? No, that one is false. Emily's race car was the most accurate. No, that one is also false. Had a negative percent error because the car didn't know that one. So Emily and Marcella had a negative percent error because their car traveled less than the desired distance. So no, that is also false. Notice because it takes in absolute value, we're not going to get a percent error that is negative. Alright, let's go ahead and read this one. Mr. Brown's class was guessing the number of gumballs in a gumball machine in the cafeteria. All the guesses were between 482 and 456. After counting, it was determined that there were actually 408 gumballs in the machine. What is the absolute value of the guesses below? So let's do 382 grab a text box over here. Our absolute error is the absolute value of actual minus measured. So in our case, it's going to be 382 minus, I guess 408 minus 382, and then for our other one, it's going to equal 408 minus 456. Alright, so when we do those two calculations, let's see, 26 and 48. Is that right? Yes, 48. What is the percent error? So we need to take this guess and divide by the actual. So I'm going to go ahead and grab my calculator here. And let's take 26 divided by 408. And we get approximately, let's see, 6.4%. Let's take our other number, 48, divided by 408. And that's approximately 11.8%. Okay. So this one was an underestimate by about 6.5%. This one was an overestimate by almost 12%. So go ahead and summarize today's lesson, talking about the formulas that you learned, everything that you've applied. Just give me a quick summary